you, David. Thanks for the introduction. I appreciate I see several familiar faces, so I feel at home. Thanks for coming tonight. A little bit about the presentation. This is going to be part 1 out of 2. I consider this one actually to be a little bit of a dry run. We plan to present an enlarged version of this talk at the IEEE Consultant Network next month. And if you look at the title, part of the reason is Edison versus Tesla. There is tons of information, and trying to compress that in between 45 minutes and to an hour is going to be a huge challenge, as you will see. So the part of steel dust is quite a bit of the section that I'm going to be covering on the IEEE Consultant Network, which is more of the Apple versus Qualcomm and how IP is seen these days, and some of the new business model that I'm using. I'm trying to do a couple of slides in that, but pretty much all of that material will be next time. Let me talk a little bit about myself. I am the founder of Invention Matters. Invention Matters is a member of Album, multinational law firm with about 27 members, multiple countries, 140 lawyers and subject matter experts, and we are their face here in Austin, Texas. In my case, with Invention Matters, what I want for you to learn about me is I'm pretty much an engineer, an electrical engineer, tons of experience in hardware and software, and for the last few years I have been working quite a bit on intellectual property. Right now working quite a bit into licensing, patent valuation, and from this group, what I want to get is I actually would like to talk to people that are very savvy with respect to web servers, cloud-based systems, and cloud-based solutions. We are trying to put in place a platform to actually license software from some of our clients, and we, similar to what Kay was explaining, we pick subject matter experts in different places. And in this case, we are trying to do something in the software space. So we'll be very interested in that, and also on people that are savvy with AI and blockchain type of scenarios. The topic, as far as Edison versus Tesla, let me tell you that quite a bit of the focus is going to be in what is called the current wars, which is the period between 1888 to 1898. Both individuals invented so much that it will be pretty much impossible to cover tonight. So I did myself some cheating, and I framed the discussion in what is considered the golden age of electricity. And I'm going to try to put a framework to it, and then I'm going to put the IP war that happens between Edison and Tesla Westinghouse in that period. And I'm going to try to bring some conclusions and some reflections for you guys to see it, because I think that you will see quite a bit of a parallel between what happened at that time and what we see happening today. So some parts I'm going to skip and try to go really quickly, and I'm going to focus on that period as I explained. 1847. Thomas Edison is born, and I just put it there for the context. He early on had an issue with deafness, and he considered actually that to be one of his main advantages, because he was able to fend off distractions from everybody else and pretty much focus his attention into what he was doing. He was a voracious reader. He went to the library in Detroit, and he didn't say which books he read, because he actually read all of them. So that gives you an idea of kind of his approach. Very hardworking. He will pride himself on the fact that he will sleep only 3 or 4 hours per day. That was it. The part that he didn't mention is that he will take a couple other naps of 1 to 2 hours during the rest of the day to complement that part. But he will come across and say every time that he only has slept that time. I put in the context of the timeline Nikola Tesla. So if you see between both of them about 9 years apart, he was born in Serbia, and quite a bit of a different individual, as I will show a little bit later in the talk. So let's get first. This is Thomas Edison, 21 years old. He comes with his first filing. And the first filing is a boat recorder, and that's what get him started, one of his main inventions. And think a little bit about this. He's just 21 at that point, and this is 1869. So let me talk a little bit about the state of affairs of where electricity is at this point in time, and what we are seeing at that point. So if you're living in the 1870s, the electricity just that you see it in two main forms. You see, of course, gas lamps all over the place. And if you're in a very luxurious block in New York, you get to see some electricity lamps powered by arc lamp systems. And these arc lamp systems are, 3,000 volts, and they are connected to this series of lamps in series. They are extremely unreliable. They require quite a bit of maintenance. And of course, there are not many volunteers to go and fix it, because it's 3,000 volts. Not other than that, I don't think there is many volunteers also to try to install any of those in-house, because it's 3,000 volts, fire hazard, safety, so is that considered to be pretty much an outdoor solution. And then you have incandescent lighting for business and residential indoor lighting. Gee, there is a problem in there. The incandescent lighting is very unreliable. Unreliable as in it lasts a couple of hours and whoops, there goes the lamp, and it's very expensive. Now, if you look at the total market of the US at that point, it's huge with respect to those lamps. About 940 lamps for the whole US. Hey, the market is just starting. You need to have some vision of what it could be. And if you want to hear to a really good book, there is one book called The Last Days of Darkness by Moore. And this is a novel of an individual that researched 5 years of the current wars, and he recreates the whole history on that period. Very, very good read. Now, let me tell you what the problem is, what's going on. The problem is a matter of distance. They haven't figured out yet how you can transmit power at a long distance. So basically, you are still penalized by the I²R, the drops and the power losses in that line. And of course, you have the problem that if you make the distance too long, well, you have too many losses. If you try to make the cable quite a bit thicker, and it gets too costly. So all these solutions, we are talking a couple of miles maximum. So under this scenario is what you got to work with. So in other words, yes, they have not invented the transformer yet. So they are working on it, but still has not come into place. Okay, let's go ahead and get now closer. This is 1869. Edison has gone ahead done his first invention. And typical of Edison, this hard-working individual that pretty much is a workaholic, 24/7, that can focus big time into problems. He comes with a brilliant idea. And his brilliant idea is, hey, let's clone myself. What do you mean clone myself? Yeah, he goes ahead and put in place what is called the Menlo Park Research Lab. That is the first industrial research lab. And you know what? Very different than what you will think of a research lab. This is a place where he as the general of this army of engineers, will identify the problems and opportunities, and he will break those problems into pieces and assign to multiple teams that will work in those problems in parallel, and they will try all the permutations until you find it, because hey, it doesn't matter how long it takes until you nail it. So they will document all these in lab notebooks, and that is his system. And you know what? It works extremely well, because soon enough you will see that a stream of inventions start to come out one after the other one, and the site starts to be known as the Invention Factory, just for that reason. So if you look at that, you start to see the automatic repeater was one of the ones that came out. Then they improved telegraphic devices, and then at that point you get the phonograph. And the phonograph was one that, you know what, that really hit and put them to be at a celebrity status. At that point, he became what is known at that time as the Wizard of Menlo Park. Because, hey, everybody can care less about a repeater or a little bit of a better microphone, but if you're a little bit old and you remember the vinyl disc, hey, this is the early version of that. This is the first record player. It doesn't look like a disc, it looked like a cylinder, but to people at that time and age, that's magic. It's an instrument where you can record voice and it can reproduce the sounds. He basically has been able to harvest the power of diaphragm that gets into the phonograph, and from that point on, Edison is reverenced as just the inventor in the US. The guy to be the guy that will show the newest stuff, the state of the art. And this is the period between 1876 to 1886. Now, I'll show this, but during that period, with that army, he's really, really busy. From that point on, Edison is not only looking at opportunities that are commercially savvy, he's actually putting in his mind a whole electrical system in place to try to solve the distance problem and to actually go ahead and get lights to all over the US, take over that market. So 1877, yes, he works and improves the telephone, but in 1878, he goes ahead and files for this patent, the 223898, and that is the first commercially practical incandescent light. So that is very interesting, because quite a bit of people had worked in the incandescent lights bulbs before him. But this was the first viable commercially incandescent light. And the reason that I bring up this patent is because, you know, you have a patent portfolio. Companies have hundreds, thousands of them. But there are a few of them that are considered to be the crown jewel of that portfolio. And this patent is one of those. This patent is the one that he will use to fend up competition, because after all, he is the inventor of the light bulb. That's the way it's portrayed in the press, and for all the facts, it's true. He's the guy that actually commercialized the light bulb at that time. And when you look at that patent, it's very interesting, because what that patent is he goes ahead and he has put in writing in the technical specification 14 different methods of how to build an incandescent light, the type of filament, how is it done, how to increase the resistance of that filament, and the backing of those light bulbs, and so on. And when you read claim 1 of that patent, very, very interesting. It says, incandescent light as described by the methods above. You know how broad that can be when you have described 14 different methods and you're using only one, but you're covering every single method that comes to mind as close as they have tried in the lab. So for the sake of the market, Edison has come out with an instrument to own the market of incandescent light. Basically, very, very hard to get him out of that position because that patent gives him the power. That's the period that I want to show a little bit. And the reason that I want to show that is because the period that is going to come out after 1880, you get the patents with respect to his electricity system. Remember that this is very early on at the time of an electricity grid. You're just giving birth to that. So at this point, companies are completely vertical. If you're going to own this market, hey, you got to create your own generator. You got to create your own power meter. You got to create your own light bulb because there is no standards at this point in time. You have to create it all, and you have to patent it, and so on. So just to give you an idea, by 1882, he goes ahead and put the first of his systems in place. And when he puts the system, hey, he gets 82 customers. And he gets a really good start, 400 light bulbs. Not bad. Hey, a couple of years before, the whole market was 943. And now he's to a good start with 400 lamps. And guess what? 2 years later, he has gone from 82 customers to 504, and he has now 10,000 lamps. Hey, not bad for a couple of years into the market. Now, the reason that I tell you that is, that was 1884. 1884, and something else, just before I get into that point, something else happens just as he is deploying, he's empowered to take over the whole market. Just a little detail happens on 1880, and that is William Stanley come out with a transformer that is actually practical, a transformer that will work very decently on AC, that is efficient, and that seems that do the job. His work is part of a continuation of a work that has been done by the Hungarian 3-engineer team called CBD. It's a team of 3 engineers in Hungary that have been working on transformers. He continued into that, and he come out with the first. That is important because that will enable AC to cash on into the 7 years lead that Edison had on them. So why do I bring this into place? Hey, I already told you 1884. He has 500 customers, 10,000 lights as a market. He has a full lab, an army of engineers, and there comes a new guy, Nikola Tesla. He comes as an immigrant, no money in his pocket, only a letter. And the letter is from his old boss in Europe. And the letter comes being addressed to Edison, and the letter says, I don't think that I have it there yet, but the letter actually says 2 things. I know of 2 bright engineers that I truly respect. One of them is you, Edison, and the other one is this young man. And that was the recommendation that Nikola Tesla had at that time. Tesla had worked for that guy where the telephone system had been placed in Budapest. And he has been helped on that project, and now came with that recommendation. He comes to work for Edison, and he comes with ideas of a better system from Europe, from fresh ideas in Europe. And those ideas, of course, are based on AC, not DC. Edison take a look at those ideas, and he called his ideas impractical. Now, let me tell you something. In the credit for Edison, AC at this point in time in history is considered to be a force of nature that is rebel, that cannot be controlled.
Dangerous.
So it's dangerous.
Yeah.
Actually, no mathematical equations describing AC has been developed at the time. It will be 5 to 10 years down the road by the time that a mathematician comes and arrange all of that for the understanding. So there is some magic, and you better stay away of this. So this didn't fit quite well into Edison's plan, who thought, hey, I come out with a DC system, 110. Nobody will die with 110. I just pop my system all over the place. By the way, we were doing fine. 10,000 lamps, 500 customers before you come in. Please don't bother me with those ideas about AC. We are good. Thank you. He comes, and there is a huge transatlantic that is in the port. They have a huge problem with one of the motors, one of the generators for all these DC lamps, and the parts have not arrived, and they need to sail soon for the transatlantic to go back to Europe. So the parts are coming from some other place, 2 days apart, and he comes, and that's the first task that they give to Edison. Hey, Edison say, hey, while we are waiting, why don't you let me try it? And voila, before the parts arrive, he has a way to fix all the system, and the system is ready to go. So he started to show promise on this thing. And then they go to the Menlo part, and there is this DC generator problem that has been banging around for many months, and the problem has not been solved. And at that point, Edison said to Tesla, if you fix this problem, I'll give you $50,000. Guess what? 2 months down the road, Tesla come back to Edison and say, he's ready to go. But then something happens. He say, I want my $50,000. And the response of Edison, being a businessman, as good as he is, Nikola, you don't understand American humor. I'll give you a raise of $10 a week. And at that point, that didn't set well for Nikola Tesla, who resigned on the spot and left the company because he felt not valued and irrespected, and he left at that point, and that's the end of them together. So 1887, he goes away with his ideas about AC systems. He starts a new company, Nikola Tesla. He gets some funding, and guess what? He gets forced out in the first company that he puts together. He ends up doing some work in the trenches and trying to survive and so on. But he stick to his ideas, file patents for it with those, and there comes Westinghouse. Westinghouse that complement the brilliance from Tesla. Tesla doesn't have that systematic way, that business view that Edison has. Tesla is just brilliant. Tesla doesn't go for that approach of let's try all the permutations. He just see way ahead of which one is the approach to take. But business-wise, market demands, how to make money with this is not really his forte, but it's something that Westinghouse is extremely good at it. And Westinghouse, who has huge credit of his own doing anti-brakes and creating many other inventions in that space, decided that, hey, he wants a piece of this market, and he sees the value of this, and he knows that he's coming late. And as a latecomer into the market, he comes very smart and say, I don't need to recreate the wheel. I can buy patents. I can put something in place to compete against Edison, and let's catch up with him and let's buy our way around. And that's when things get very interesting into a period called War of Currents, when you look into history. That is what you see in the picture is a catalog of the system by Westinghouse. He had already put a catalog together with the main pieces, and I will show it in a moment. Let me show a view of what they have in mind at that point. At this point, the market price that every one of them envision is, you know what? The indoor residential market. That's where the volume is. That's what is not being serviced at the time. So that's what Edison has in mind with his solution. That is Westinghouse wants to achieve too. And the distance issue is still there. There comes Edison. Edison, of course, he has his own DC current generator. He's a 110 volt DC incandescent lamp, which he feels very proud about it. Is the default solution for the market. There is no better lamp at that moment. And he has his own electric meter to charge people proportionally to the consumption. And he has, of course, a great disadvantage, which is the issue with the short useful transmission range. What does that mean? That means that you have to sell one generator at a time. Because the transmission range is so short, you have to basically convince every municipality or neighborhood one by one to buy your system, because you can only cover what is around that point, and you need to find concentrated areas to try to cover. And then there comes Tesla, who says, hey, AC systems, I think that if we can solve the issues, we can beat DC, because our range, eventually, we don't know how, but eventually we gotta be able to use transformers and get to a better range, and so on. So he has his AC systems. He starts to see the light of what we use today, of a step up, the voltage, transmit, a step down to something reasonable, and minimize the losses in the transmission. And he can tackle all the customers that Edison cannot tackle. Basically customers in between. You can put a system that is powerful enough and people will just connect to it. Now there is a challenge. The challenge is they are late into the market. Thomas Edison has already been there for several years with his team, with his system. Very, very difficult to kick out. And now, in addition to that, you have the issue that, hey, every one of them is pretty well protected. Edison consistently has gone and has patented every single part of his system to defend it very well. So hey, he knew how to manage manage the system and be very well covered in that sense. He has patented the incandescent light, the generator, the electric meter, and he is in a very strong position. Tesla, in his case, Tesla with Westinghouse, in this case mainly Westinghouse, he has the patents from Tesla, which is the polyphase AC system, and then he for the lamp, he says, well, you know what, we're not going to reinvent the wheel, let's go ahead and use some patents from Sawyer-Mann land. He has some patents that are earlier patents than Edison. And this is a very strategic point, because what he will do is he will try to use a version of those lamps. And when he gets sued by Edison later on, he will counter-sue Edison and say, actually, your patent on incandescent light is an infringement on my earlier patent. on Sawyer map. So he has the chess game right set up for that purpose when he licensed exclusively those patents at that time. And then they designed their own meter for their solution. And of course, doing all of that, they have a huge challenge. They have the system from Edison, but since they bought their way around, they are starting to run low in cash. They have been just spent way too much money, and now JP Morgan, as a good banker, is looking at them as a possible takeover too. So they have their own challenges at this point. Now, just when things are about to get hot, then there comes the patent, the case of the patent 223-898, which is the one that I was saying. And let me just cover that a little bit really quickly. Basically, Edison, hey, he is considered at this point the father of the electric lamp. Okay, that's his baby, his invention, and not only that, the court is looking at that patent as this has such a broad coverage as very little space for somebody to come around that. So it doesn't matter. It doesn't matter that Westinghouse and Tesla have all these patents of his system. What he is saying now is, you know what? You can do whatever. But since I own the incandescent light, I'm going to sue you, and I'm going to sue every one of your customers to see if they do business with you. At that point, 312 lawsuits, imagine that. This is considered to be the $1 billion lawsuit of that century, the big one. And not only that, at that point, Edison is 10x the size of Westinghouse, and of course, he has a 7-year lead. So you can see how this is kind of an unbalanced fight. I mean, Edison is in such a huge position, and he's so savvy as an strategic thinker. He's not only an inventor, he has thought about all these things to position himself for battle. And then you have Westinghouse and Tesla trying to get a piece of this market. So at this point, Westinghouse goes ahead and hire this lawyer, Paul Cravath. And you gotta decide, is this a brilliant move or an insane move? And why insane? Paul Cravath is #1 student out of Columbia Law School. However, he's just a new grad. He has never tried a litigation before, and he is put there to lead the team for Westinghouse. Well, you know, you could say that he's a little bit out of his league, of course, but the guy is brilliant. And the book that I just mentioned, actually, that novel is completely based on his life, and quite a bit of what the novel is based is true, by the way, in everything that I could check. But there are actually some reasons why Westinghouse is doing that, and they are, most of the other lawyers either have business done with Edison, which is the main force in the market, so they have conflict of interest, or they are doing some work for JP Morgan, who is the main backer for Edison. So in reality, it's not that there is many options. Plus, there is the other fact that any other very well-known lawyer doesn't want to take a case that they consider to be a lost cause, because they don't want to have that ding in their file as the guy that lost against Edison, and as the fool that dared to take a case with 312 lawsuits pending against you. So that is there. Now, the way that Cravath approached the litigation, I think that is brilliant and shows some of the intricacies of the case. he says, did Edison invent the electric lamp? And when I say the electric lamp, the reason is, you know what? Many patents are nothing but an extension of what has been done before. It's an improvement, as long as it's a significant improvement and is novel and is non-obvious, you get a patent on it. That doesn't mean, however, that you're not infringing on a past patent. You can have a significant improvement, but if it's based on something that was done before that is covered by another patent, you're still infringing. So, Cravath went ahead and studied Edison quite a bit and looked at his lab and realized that Edison has this invention factory with all these teams of engineering and so on. And he says, you know what, there is nothing that would stop me from recreating what he has on the legal front. So he goes ahead and take a crew of the best students back at his alma mater at Columbia, and he put them to work at minimum wage, you know, the pizza type, where you eat pizza and you charge as little as possible. And he coined the term, not a clerk, not a lawyer, an associate attorney, even though they are not fully graduated yet. And you get this full crew of quasi-lawyers that will go through all these patents and try to figure out to see if there is some prior art that they can paint on Edison. And they do such a magnificent job doing this that when this case is done, actually industry copied the system of Cravath. And that's the reason that you see now this huge team of associate attorneys. And he actually part ways and do his own firm, and Cravath become a main player for litigation and so on. Now, unfortunately, even though they try to, in our days, it will be an IPR of the patent. They are trying to invalidate his patent. But really, they try and look and search and appeal to the court. But it was decided that, hey, remember that Edison approach is actually try all the permutations, not to base this stuff in one of them, but just to discard them. And actually, the invention proved just that. It proved that, hey, his invention actually is not building on top of one, it's just a unique, separate way of doing things. So it's not invalidated due to that procedure, even though they do all this work. And then on the second question, who is the inventor of the patent? Hey, you look, and Edison invented 1,093 patents. Very prolific. But guess what? If one of those patents, for some reason, doesn't give credit to some of the other inventors and so on, we can invalidate it. So Cravath say, hey, who's the inventor? Who really is the inventor of that incandescent light that is being used? Because you have this full army of engineers. Certainly somebody else did some substantial work that needs to be included as an inventor too. So they do this humongous amount of work on trying to see who else work in the lab and so on. Unfortunately, Edison had to split the problem in sections and have give different parts of the problem to different teams, to the point that where they put all this work together, they realized that it's true. Other than Edison, nobody else can be considered as a significant contributor to the electric lamp. So once again, they are out of luck in that part. So all of this is the work of Cravath trying to invalidate and go after Edison. Now, no good IP current work will be valid if you don't have some fake news related to that. So if you're saying that the fake news term is new in this time and age. They already tried that one back then in that century. And at that point, Edison is working a different front. You have Chadwick, which is the father of the electric chair. And as he is looking for a way to implement the electric chair, Edison, who is something that on the record has been opposed to the electric chair, come back to Chadwick and says, you know what, I think that the best system for you to use is, of course, an alternating current system, like the one done by Westinghouse. And that is, of course, to suggest that AC is more dangerous than DC and win the war that way. And that goes on for quite a while. The electric chair is used in 1880. It gets to a point where Chadwick goes ahead and buys some generators from Westinghouse, and he buys those illegally and use those generators for the electric chair. And Westinghouse, in order to try to save the brand, goes ahead and legally pay for the appeal of the inmate that is going to be used as the first guinea pig for the electric chair. And still it gets defeated, and they use the electric chair, and after that you are in a PR nightmare, because after that, you know how they call, if you live through the 80s and 90s, you remember that a copy of a document was called as Xerox, because most of the machines was Xerox, so you refer to a copy as a Xerox. It was just a term that was coined. Well, for electrocution of people, they coined a term at that point, and they call it Westinghousing. That was not pretty. That was nasty. You know, you're trying to put a market in place, and after that, the market cash on into this term. So it's really, really, really bad. Now, just as if you think that things cannot get worse, Edison goes ahead and sends an 84-page document titled "A Warning from the Edison Electric Light Company" to all the newspapers and future prospects of customers for Westinghouse, making his case that AC is way more dangerous than DC. And he keeps on doing this. And in addition to that, an unbiased, and I put in quotes, expert, an electrical engineer called Harold Brown comes into place. And Harold Brown claims that he is not being paid by anybody. He just is there for the sake of the truth. And at this point, he gets some people some young people in cities, and he paid them 25 cents, and for 25 cents, they go ahead and look stray dogs that they will bring to him, and he will do these demonstrations, and he will put the dog in a cage, and then he will apply 300 volts DC to the poor dog, and this is DC voltage, and the dog will not die. He'll say, look, it doesn't die, and then he increased the voltage to 500 volts. Still, the dog is fine. Then they increase it to all the way to 700, and in some cases to 1,000 volts, and the poor dog still survives. And then he goes ahead and brings the system from Westinghouse and applied 330 volts and killed the dog. And he says, see, I told you. I mean, it's cruel. But what proof? What other proof do you need? An elephant. Yeah. And they of course they go ahead and later on do that with an elephant also. But he's doing this all over the place. Later on in history, he will be uncovered, and some letters will come to public to show that the treasurer from Edison Company is actually financing Harold Brown. and that is being paid by the company. Now, just when you think that there is no way to fight Goliath, that fighting Goliath is futile, there comes a David to fight him way to a different level. And that David is Nikola Tesla, because he may not be he may not be this businessman, but he's brilliant, and he will bring a way to demonstrate and prove that Edison is wrong. Another than that, some electricians and people have some questions about Brown's methodology. Some people from Westinghouse say, well, you know what, I have been hit at 1,000 volts, and it kind of dazzled me, but I'm still alive here. And for many electricians, the saying was, is volts that jolts, but mills that kills. Meaning the current is really that what kills you. You can stand a higher voltage and you will be fine. At this point in time, Tesla goes ahead and invented the Tesla Coil. And with the Tesla Coil, he's able to prove that at high frequency, AC at 1,000 volts is not as dangerous as suggested by Edison. And when you look at some of the pictures from Tesla in his labs and so on, you can imagine that something like this is as cyber futuristics in the 1800s as it gets. I mean, you look at these pictures, is a case of a picture is worth 1,000 words. I mean, it really disproves the case, and so on. And not only this, after that, he gets invited at a later time to the AIEE, the American Institute of Electrical Engineers. That is not only different than the IEEE today. That is their earlier version. And he gets invited to one of their technical meetings, and basically what they are saying is to Tesla, why don't you give us your insight of this story? And he said, okay, I'll try to do some, and so on. And he comes with this huge experiment using his induction coil and so on. And he basically come with a demonstration that is nothing short of almost magic for this time, because by that time he is sparks are coming out of his fingers, and he is able to touch high voltage on one side, and he's lighting a bulb in the other hand, and he's basically completely disproving the fashion, and he's saying, look, if you handle AC at a high voltage carefully, it's definitely not as dangerous as Edison is saying. And this is what electrical world had to say about the lecture at that time. But not only that, he also came to a point where he threw a dart at Edison, because he came back with a new light bulb. The new light bulb was vacuum and didn't have the filament. And the bulb, of course, if it didn't have the filament, it was not an infringement on Edison patent. And he did a couple of things with that bulb. One, he light up the bulb with a high voltage AC. And not only he did that, and he was using his own body, but by that time he was a pioneer on the skin effect, basically current going through the surface without damaging the structure, which was very new at that point, and he was experimenting with that. But not only did that happen, he proved with that AC was not as dangerous as Edison was claiming, but also he light up that bulb that he had in his hand. And by the way, he put the best bulb from Edison in his system beside him, and He didn't say anything, but his bulb was a lot brighter than the one from Edison. And that, of course, didn't make Edison happy at all, because he was in front of basically the IEEE, and it was a demo that everybody could see, and he was completely being disproved at this time. And it was 1891. So by this time, all the IP wars have gone back and forth. A lot of money has been spent, and Cravath is on the losing side of that equation with that patent. Basically, the patent from Edison stand, but the market has decided, and the market is going AC, and there is nothing that can be done in that regard, and the economic forces remain, and Cravath come with a brilliant move as a patent attorney. He says, I'm fighting this the wrong way. I don't need to fight Edison. He's right, he owns the patent. But JP Morgan owns Edison because he is backing Edison. And JP Morgan is a businessman. And he goes ahead and schedules an appointment with JP Morgan and say, look, why are we wasting all this money? Let's do a patent sharing agreement. And he gets to a settlement and does a patent sharing agreement. In that patent sharing agreement, JP Morgan not only does that, but he also merged Edison General Electric with Thomson Houston. Thomson Houston, just the year before, was a competitor that had AC systems. And basically what that tells you is that JP Morgan already had seen the light that AC system was going to win the war. He merged with Thomson Houston, and the president of Edison General Electric, which was a guy by name Billionaire, actually helped to orchestrate that move. Because of all the financing, Edison had already lost the majority stake on the company, so all of this happens behind his back. He learned this only the day before the merger happens. And when the merger happens, actually Billionaire, who thought he was going to be on top because he was with the Edison company, actually ended up being laid off. And the guys from Thomson Houston get paid, put them on top, because that was AC, and they had the patents on AC. They have the soldier man lamp patents on that case too. And in that case, at that point, Edison realizes that, you know what, resistance is futile, and not only that, the one thing that hurts the most to his pride is his name is removed from the company. From Edison General Electric, now is what we know today as General Electric at that point. And now, from a business perspective, they end up owning 75% of the market, and the market has gone from 15 companies down to 2 companies at that time. So, which is Westinghouse and General Electric, all of them own all the IP. They dominate the market at that point. Some of the things really come into place. Westinghouse bid for this big show, the World's Columbian Exposition, 93,000 lights at the time. Big show, they dazzle everybody, and as a result of that, they gained the contract for one of the dreams from Nikola Tesla, which was to harvest the power from the Niagara Falls, and they get the contract and get to build one of the power plants, which is one of the dreams from Nikola Tesla, to actually get that going. Unfortunately, the sharing agreement, a couple of things happened. By 1907, Westinghouse was in a really tough position economically after all these lawsuits and so on. And Westinghouse approached Tesla and said, I need help from you, because the original contract say that he was going to be paid royalties $2.50 per horsepower generated from every one of those generators that get sold per horsepower. So you know what happens at that moment? At that moment, Nikola Tesla go ahead and say, okay, I'll help you out. And he tore the contract, that contract that they had. And in exchange, he got a lump sum of about $202,000 and some more. But at that point, Nikola Tesla pretty much threw the opportunity to become probably the first billionaire in history, because 10 years later, the electricity market boomed. If he would have maintained the licensing agreement that he had, or if he would have said to Westinghouse, I understand that you're in a bad spot, I will waive my royalties for the next 5 years. But at that point, it will get reinstated. It will be a whole different story. The Tesla patents for Westinghouse at that moment, the bankers consider that they were valued at least 12 million, which will be comparable to $300 million of our time. And the market boomed in such a way that it will be a whole different story at that time. From the part of Edison, he cashed out. He faced to the public, he said that he did pretty well. Of course, economically he did really well, but he always was upset that he lost the war in that sense. Later on, he said to the son of William Stanley, which is the inventor of the transformer, hey, you know what, I was wrong, basically. Tesla died in 1943, penniless. Westinghouse ended up actually paying the account for his hotel where he died and so on. He was always loyal to Westinghouse in that sense. Edison, his system actually carried on, because after this he went into work into batteries and into mining and into some other stuff, and his worth was about 12 million when he died. He did most of his million through royalties, as he had done at the beginning. So the moral of the story, those who cannot remember the past are condemned to repeat it. And I just want to finish with a couple other slides with respect to what is coming, and this is more of my personal view. When you look at traditional patent flows, this is what you see in companies. Most of the time you have C-level, you have an MRD, a market research document done by marketing. You see research and development, you see IP counsel doing the patent filing at the end, and there you go. You submit a patent just before you go ahead and launch a product. I'll say that model has several disadvantages and is broken in several parts. For one, is patenting is left as an afterthought at the very end. Basically, oftentimes you don't do any prior art or search. You leave that to the USPTO. As a result, basically you end up narrowing the claims at the very end. And oftentimes you don't give true consideration to litigation and licensing when you follow this paradigm. From a filing perspective, you also have the disadvantage that the invention is different. The expertise of an inventor oftentimes doesn't match the expertise of the patent attorney, and that is very well known to happen. Oftentimes, the patent attorney has not practiced engineering for the last 15 or 20 years. He may have taken basic programming or Fortran when he went to school, and now he's covering a cloud-based system on Python or something that is very, very different. So the patent is just as strong as the understanding of the lawyer. So there is quite a bit of limitations on that approach and so on. But the part that I want to bring in is times have changed. We are reliving a stage similar to the time of Edison and Tesla, where, hey, you have new markets being created with blockchain, with Bitcoin, with IoT, with AI and so on. And as much as the opportunity is in there, the IP times also have changed. When you look at what some of the big companies are doing, the old way of thinking of patent is a form of protection doesn't hold any longer. The actual thinking is, you know what, patent is an offensive weapon. It's something that if you cannot enforce, the value is not really there for what you're trying to do. So as something that I want to show is I want to give you a sample of it. If you look at Qualcomm is a company that is a chip manufacturer. And this graph tells you quite a bit. If as a chip manufacturer, Qualcomm is exposed to Moore's law. But what you're seeing here, and this is for 2016, you can see there are two divisions. The one on the left is the chip making, and the blue graph is revenue, and the yellow is the income, basically the money that they did from chip making. And the one on the right is the money that they make through licensing. And when you look at this, you realize that they are very successful with their IP model. They're basically making way much more money into licensing their IP than actually making chips, which is where the engineering force is. And this is topic for quite a bit of discussion next time that I'll talk about this. But I just wanted to show you that graph and put it in perspective. This is a model that is used by many of the Fortune 500 companies, which is basically they use a team of subject matter experts. And I see the company of my friend here, Kate, does quite a bit of this with her team of experts, which is basically you look at patents in a different way, and you look at a way to customize patents such that they enhance the values and map towards the infringement of the competition. I believe that you can use a similar model and do that upfront, not wait until the patent issue, but from the very beginning put a patent expert and a lawyer and actually come out with a very strong patent from the very beginning. Because you have basically both litigation and prosecution all combined at once. And that is the model that we are using at Invention Matters right now. We are basically with the model of transforming ideas into disrupting patents and connecting inventors to investors. I want to finish the talk with a paraphrase of Clint Eastwood's words. Instead of saying a man got to know his limitations from the movie, I would say an inventor got to know his licensing options. Thanks a lot. Thanks a lot for coming.